All right, welcome to The Explainer. Today, let's talk about the weather. Why even with all our incredible technology, it can still feel like a complete coin toss. But what if the secret to a better forecast wasn't just about building bigger supercomputers? What if it was about teaching an AI to actually understand one of the most chaotic things in nature? Clouds. I mean, we've all been there, right? The app on your phone promises a beautiful, sunny day, and then an hour later, boom, you're scrambling for cover in a surprise downpour. It really makes you wonder, why is predicting the weather just a few hours from now, what the experts call nowcasting, so darn difficult?
Well, it turns out the culprit is usually hiding in plain sight, right above our heads. It's the clouds. They are the ultimate wild card in any short-term forecast. They can form, shift, and completely vanish with this incredible complexity that has, frankly, been a massive headache for forecasters for decades.
So let's get into it. Let's break down exactly why clouds are such a nightmare to predict. Because honestly, once you get a feel for the scale of this challenge, the solution we're about to look at becomes even more incredible. You see, until very recently, forecasters were kind of stuck between a rock and a hard place. On one hand, you have your traditional, massive weather models. They're great for telling you the temperature next Tuesday, but they see clouds as these giant, simple blobs that completely miss all the fine-scale, chaotic action. And on the other hand, early AI attempts gave us, well, these blurry, fuzzy smudges. A forecast so vague it was basically useless. And that really gets to the heart of the problem. The team behind this project knew that the old methods just weren't cutting it. I mean, think about it. A blurry blob of a forecast for a potential thunderstorm doesn't really help you decide if you need an umbrella, does it? They knew they had to build something way sharper, smarter, and just more realistic.
And that brings us to the solution from a team called Entangled Minds. And what they've built isn't just a tiny improvement. It's like they threw out the old playbook and wrote a completely new one for forecasting weather with AI.
So what is this thing exactly? At its core, it's a really sophisticated deep learning system that just pores over satellite images to predict what clouds are going to do next. But here's where it gets interesting. Its real power comes from how it fuses together three different kinds of information: what a cloud is made of, its actual physical shape, and, this is the crucial part, how it's been moving and changing over the past hour. It's that complete 360-degree view that changes the whole game.
Okay, so let's pop the hood on this thing, because the way this AI is built, its architecture, is where the real magic is happening. How does it actually go from a bunch of satellite pictures to a forecast you can actually rely on?
The whole process is actually super logical. You can think of it like the AI is following a four-step thought process, almost like a detective. Step 1, it gathers all the evidence. Step 2, it canalizes the past to look for clues and patterns. Step 3, it comes up with a theory about the future. And finally, Step 4, it does a reality check to make sure its prediction isn't just some wild guess. So let's walk through each one.
First things first, the evidence. The AI takes in images from three key satellite channels. You've got visible light, basically what our eyes would see. And then you have two different kinds of infrared, which are super useful because they reveal things like temperature and what the cloud is made of. And here's a really clever little trick. It intentionally ignores a fourth channel, the water vapor one, because it can be kind of noisy. This keeps the whole system focused and more efficient.
Okay, next up, the AI has to get the backstory. There's a special part of the system called the Temporal Spectral Module, or TSM, and you can think of it as the AI's short-term memory. It looks at a whole sequence of images from the last hour and learns the cloud's habits. Is it moving fast? Is it spinning? Getting bigger or smaller? It soaks up all that history to get a sense of the trend. Now we get to the main event, making the actual prediction. This all happens inside a powerful architecture called a U-Net. But here's the secret sauce. It gets help from another module called Film. The best way to think about Film is like a little expert whispering in the U-Net's ear. As it's building the image of the future, Film is constantly feeding it reminders from the past, saying stuff like, "Hey, remember, this whole system was rotating clockwise." This makes the final prediction incredibly smart and aware of the context. And finally, one last step, the reality check. A final piece of the puzzle, the Temporal Consistency Module, basically acts like a physics engine. It looks at the AI's predicted movie of the future clouds and makes sure the motion is smooth and physically believable. This is the quality control step that prevents the AI from predicting something totally bizarre, like a cloud that suddenly teleports across the screen or just vanishes into thin air.
So you put all those pieces together, and what you get is way more than just another forecaster. You get an AI that's genuinely, well, smarter. So let's quickly recap what makes this whole approach so different and so innovative.
This table really sums up the brilliance of the design. You've got the TSM, which builds that rich memory of the past. Then you have the UNet and film working together. That's the brain of the operation, letting the prediction adapt on the fly based on that memory. And finally, the TCM, the physics cop, grounding everything in reality. It's this whole system, past, present, and physical laws, that lets it go way beyond just a simple guess.
But here's a critical question. How does the AI even learn what a good prediction is in the first place? Well, it's trained using this really clever goal that's basically a constant tug of war. On one side, it's being told, be perfectly accurate, down to the last pixel. But on the other side, it's being told, make it look realistic, like a real cloud. This forces the AI to produce forecasts that aren't just mathematically correct, but that also look right to a human expert.
So that's the tech deep dive. But what does all this actually mean for you and me, for the forecast we see on our screens? What does a better forecast really look like?
Well, the difference is, honestly, it's night and day. On one side, you've got the old AI methods, blurry, inconsistent. It just looks like a crude guess. But then, look at the output from this new AI. It's sharp. You can see the realistic structure and motion. You can actually make out developing storm systems. It's a world of difference.
And the benefits in the real world are huge. First, you get more accurate predictions, not just about where a cloud will be, but its type and how intense it might be. Second, the model is super efficient, so it doesn't need a giant supercomputer to run. And third, this is a big one, it's tough. If there's a missing satellite image, it doesn't just crash. It can intelligently fill in the blanks. It's not just a better model, it's a more reliable tool.
This quote really just hits the nail on the head. This system isn't just playing connect the dots, drawing a straight line from where a cloud was to where it might go. No, it is learning the complex dynamics of cloud behavior, the trends, the rotations, all of it, to give us a forecast that actually understands how the atmosphere works. And that kind of leaves us with a fascinating final thought. We've just seen how an AI can learn to make sense of the beautiful chaos of clouds. So, what's next? What other incredibly complex, dynamic systems, from the wild swings of the stock market to the unpredictable flow of traffic in a city, what could we start to understand and maybe even predict with this kind of intelligent, context-aware technology? It feels like the sky is no longer the limit.